Behavior of perfect gas and kinetic theory. Gas laws. The condition of a gas is described by its volume V, pressure P, and temperature T. Change in one of these quantities affects the other. This leads to three gas laws, namely Boyle's law, Charles' law, and Gay-Lussac's law. Boyle's law. Robert Boyle, an English physicist, investigated the effect of pressure on a given mass of a gas. He found that the volume of a given mass of gas is inversely proportional to the pressure applied to it when the temperature is kept constant. That is, if V is the volume of a given mass of the gas subjected to a pressure P at a constant temperature, then V is inversely proportional to the pressure applied, or PV is a constant. This can be written as P1V1 is equal to P2V2 is equal to P3V3. This indicates that if pressure is doubled, the volume will be halved. The graph between P and V is not a straight line. It is a rectangular parabola. Charles' law. A.C. Charles studied the variation in volume of a gas with temperature and experimentally established that the volume of a given mass of a gas changes by a constant fraction of its volume at 0 degrees Celsius for every 1 degree Celsius variation in temperature at a fixed pressure. This relation is called the law of volume or Charles' law. According to this law, the volume of a given mass of gas is directly proportional to the absolute temperature when the pressure is kept constant. The mathematical representation of Charles' law is Gay-Lussac's law. Joseph Gay-Lussac experimentally studied the variation of pressure of a gas with temperature. According to Gay-Lussac, at constant volume, the pressure of a given mass of a gas is directly proportional to the absolute temperature. The mathematical representation of Gay-Lussac's law is mole. 1 mole is the amount of substance that contains as many atoms or molecules as there are in 12 grams of carbon-12. The equation of state for an ideal gas and ideal gas law. Most of the gases are found to obey Charles' law and Boyle's law, approximately within fairly wide limits of pressure and temperature. If a gas obeys the gas laws at all temperature and pressure, such that its molecules are free from intermolecular attraction, then it is called a perfect or ideal gas. On the basis of the Charles and Boyle's laws, the equation of state for an ideal gas is deduced. The equation PV is equal to nRT is known as the equation of state for an ideal gas or the ideal gas law. Kinetic theory of gases. Important formulae. Click on each link. Pressure. Pressure exerted by N molecules of an ideal gas on the walls of a container of volume V is given by the equation where small v is the velocity of molecules. Average translational kinetic energy. Average translational kinetic energy per molecule is given by the equation where Kb is the Boltzmann constant. Total translational kinetic energy. The total translational kinetic energy of N molecules of gas is given by the equation. Note, here we have considered Boltzmann constant Kb to be equal to R by Na and the number of molecules N to be equal to N by Na. Root mean square speed. The root mean square speed or RMS speed of the molecules is given by the equation where small m is the mass of a molecule of gas and capital M is the mass in kilograms per mole. Degrees of freedom. The degrees of freedom of any dynamical system are defined as the total number of independent coordinates required to describe the configuration of the system completely. For example, a monoatomic gas molecule which has only one atom has 3 degrees of freedom, and a diatomic gas molecule has 5 degrees of freedom. The possible motions of a diatomic molecule are shown here. Theorem of equipartition of energy. Theorem of equipartition of energy states that for a dynamical system in thermal equilibrium, the energy of the system is equally distributed amongst various degrees of freedom, and the energy associated with each degree of freedom per molecule is half kB/T. Mean free path. A moving molecule collides with other molecules in a random fashion. The average distance traveled by a molecule between 2 successive collisions is called the mean free path. Mathematically, mean free path is given by the equation. The mean free path increases as the number of molecules per unit volume decreases. The mean free path also depends on temperature and pressure of the gas. Avogadro number. The number of atoms in 12 grams of carbon-12 is called Avogadro number, and the accepted value is 6.02 into 10 to the power of 23.